Hello to everyone. Welcome to Gate Concept. So in this session, we will discuss objective question of fundamental of electrical and electronics engineering 2002-2004 that was held in the year 2022 even examination. So before starting this session, please like and subscribe this channel. Also share this channel to other polytechnic college. Okay. So let's start the session today. First question is, a device having characteristics very close to that of an ideal voltage source is vacuum diode, Zener diode, transistor, or FET, that is a field effect transistor. So we know about the Zener diode that it is used to regulate the voltage level. It generates a fixed output voltage that remains constant for any change in load condition or input voltage. So the device Zener diode having characteristics very close to that of an ideal voltage source. So the right answer for this question will be option number B. Okay, coming to the next question. An atom is said to be ionized when one of its orbiting electron is raised to an higher orbit, jumps from one orbit to another, comes to the ground state, and the last is completely removed. So the right answer for this question is, we know all about the atom that it is said to be ionized when one of its electron is completely removed. जब वो पूरी तरह से हट जाता है तो हम कहते हैं कि एटम आयनाइज्ड हो गया. सो द राइट आंसर फॉर दिस क्वेश्चन विल बी ऑप्शन नंबर डी. Next, resistance of wire always increases if temperature is reduced, temperature is increased, number of free electrons available become less, number of free electrons available become more. So the right answer for this question will be number of free electrons available become less. In this case, the resistance of wire always increases. Fourth, a dependent source, maybe a current source or voltage source. It should be maybe a current source or voltage source. B is always a voltage source. C is always a current source. D neither a current source nor a voltage source. So the right answer for this question will be maybe a current source or voltage source. So you all know about the definition of dependent source. The dependent source, if its magnitude is affected by change in parameter of circuit, if its magnitude is affected by change in magnitude of any parameter of the circuit, then it is said to be dependent source. If its magnitude is not affected with the change in magnitude of other parameter of the circuit, then it is independent source. So it may be either a current source or voltage source. So the right answer for this question will be option number A. An ideal op amp is an ideal. First option is voltage controlled current source, voltage controlled voltage source, current controlled current source, or current controlled voltage source. We know in case for an ideal op amp, for an ideal op amp, output voltage is A into input voltage. So it is a which type of source? It is a voltage controlled voltage source. It is a voltage controlled voltage source. So right answer for this question will be option number B, voltage controlled voltage source. 6, for a step input, the output of an integrator is. So here what we will do, first of all I will make an integrator. Okay, first of all I will make a integrator. Okay. This is integrator circuit. Here is input voltage Vi, let us suppose, output voltage V naught. This one is the capacitor. इसके क्रॉस का जो वोल्टेज है वो VC है, ये R है, ये ग्राउंडेड है. अकॉर्डिंग टू द वर्चुअल ग्राउंड कॉन्सेप्ट यहाँ का वोल्टेज भी क्या हो जाएगा, जीरो हो जाएगा. ठीक है. तो जितना करंट यहाँ फ्लो करेगा वही करंट यहाँ फ्लो कर जाएगा, क्योंकि आइडियल ऑप एम्प के केस में इधर कोई करंट नहीं जाएगा। ठीक है, तो हम देखते हैं कि स्टेप इनपुट के केस में इसका जो आउटपुट इंटीग्रेटर का क्या मिलता है। तो यहाँ पे क्या होगा कि हम यहाँ लिख सकते हैं, यहाँ का वोल्टेज जीरो है, यहाँ का वोल्टेज वी नॉट है, तो जीरो माइनस वी नॉट कैन बी रिटर्न एज वी सी। ओके, सो वी नॉट इक्वल टू माइनस ऑफ वी सी, जीरो माइनस वी नॉट equal to VC. Okay, same current will flow. If we consider ideal op amp, then no current will pass into inverting terminal and non-inverting terminal. No current will pass. 0 ampere in case of ideal op amp. Okay, so current here can be written as VI by R, and 0 minus V naught can be written as VC. So V naught equal to minus of VC. Okay, and we know in case of capacitor, current is C dV by dt. So so dV by dt can be written as I by C. So dV can be written as I by C into dt. So if you integrate, then it will come out to be 1 by C integration of I into dt. So VC can be written as 1 by C integration of I into dt, and current can be written as in this way. Okay, so output voltage will be equal to R constant है, C constant है, VI integration of input voltage. What is VI? VI is the input voltage. VI is the input voltage. This is the input voltage. Okay. So basically, for a step input, so if we apply a step input, so we all know the integration of a step will produce a ramp function. Integration of unit step function will produce ramp function. Will produce ramp function. So here in this case, for a step input, the output of an integrator is a pulse, a triangular waveform, a spike, or a ramp. So the right answer should be for this question will be option number D, that is ramp. The op amp can amplify first AC signal only, DC signal only, both AC and DC. It should be here AC. None of the last option is none of the above. So the correct answer for this question will be both AC and DC, because op amp amplify the both AC as well as DC signal. So the right answer for this question will be option number C. Next, a logic gate. A logic gate is an electronic circuit. Is an electronic circuit which operates on binary algebra. We know a logic gate uh, is an electronic circuit which perform which perform logical decision, logic decision. Okay, so uh, according to this concept, it operates which operates on binary algebra. No, perform arithmetic and logic function. Yes, it should be the right answer. Next option is allow half electrons one in one direction. No, alternates between 0 and 1 value. No. So the correct answer for this question will be option number B, that which perform arithmetic and logic function, because it logic gate is an electronic circuit which perform logical decision. Okay, so the right answer for this question will be option number B for this question. Three Boolean operators are. So three Boolean operators will be and or not, and or not. So the right answer for this question will be option number A. Okay, not and nor, no, not and or no, no, nor or not, nor and not. So the right answer for this question will be and or not. So the right option for this question will be option number A. The magnetic material exhibit the property of a magnetization due to speed. This should be not speed. This should be spin. So because of the spin of nu nucleus, spin of electrons, orbital motion of electrons, all of the above. So the right answer for this question will be all of the above. The magnetic material exhibit the property of magnetization due to all of the above: spin of electrons, spin of nucleus, and orbital motion of electrons. Okay. So the right answer for this question will be option number D. The conductance of electrical circuit is analogous in magnetic circuit by flux, reluctance, permeance, or relative permeability. So we know एक टेबल बना लेते हैं कि और भी क्वेश्चन क्वेश्चन पूछे जा सकते हैं. ठीक है. इलेक्ट्रिकल सर्किट एक तरफ हम लिखेंगे इलेक्ट्रिकल सर्किट और दूसरी तरफ मैग्नेटिक सर्किट. ठीक है. अगर करंट की बात करें तो इसका जो एनालॉगस है इन मैग्नेटिक सर्किट में वो होता है फ्लक्स. ठीक है. अगर ईएमएफ की बात करें इलेक्ट्रिकल सर्किट में तो उसका एनालॉगस होता है एमएफ इन मैग्नेटिक सर्किट. अगर हम थर्ड रेजिस्टेंस की बात करें अगर हम रेजिस्टेंस की बात करें तो इसका एनालॉगस होता है मैग्नेटिक सर्किट में रिलक्टेंस. तो ये सारे क्वेश्चन पूछे जा सकते हैं. ठीक है. अगर कंडक्टेंस की बात करें इलेक्ट्रिकल सर्किट में तो मैग्नेटिक सर्किट में ये होता है परमियंस. ठीक है. और अगर रेजिस्टिविटी के बारे में भी अगर पूछ दिया जाए रेजिस्टिविटी तो इसका आई थिंक रिलेक्टिविटी होता है मैग्नेटिक सर्किट में. सो ये सारे क्वेश्चन पूछे जा सकते हैं. सो द राइट आंसर फॉर दिस क्वेश्चन विल बी कंडक्टेंस है तो परमियंस इन मैग्नेटिक सर्किट. दैट इज ऑप्शन नंबर सी. The principle of dynamically induced EMF is utilized in a chalk, transformer, thermocouple, or generator. We all know the principle of dynamically induced EMF. That's there should be a relative motion between the conductor and the magnetic field. So there is no such induced EMF in it seem to be chalk or in transformer. So the right answer for this question will be that is option number D. That is generator, because there must be relative motion between the conductors and the magnetic field. So in case of generator it can be seen. So principle of dynamically induced EMF is utilized in case of generator. The unit of inductance is, we all know, unit of inductance in Henry. Okay, in Henry. Volt second per ampere. Wherever according to the definition of inductor it should be flux by current. Flux by current. So we know the unit of flux is Weber and the unit of current is ampere. So again this is also the right answer, Weber per ampere. हेनरी तो स्टैंडर्ड नोटेशन है ही, जो स्टैंडर्ड यूनिट है इंडक्टेंस की वो तो हेनरी ही. तो हेनरी भी सही है, वेबर पर एम्पियर भी सही है. ठीक है. वोल्ट सेकंड पर एम्पियर ये भी सही है, वोल्ट सेकंड पर एम्पियर. सो इसका राइट आंसर क्या हो जाएगा? ऑल ऑफ द अबव. यूनिट ऑफ इंडक्टेंस इज हेनरी, वेबर पर एम्पियर, वोल्ट सेकंड पर एम्पियर एंड ऑल ऑफ द अबव. सारे ऑप्शन सही होंगे इसके. ठीक है. हमें ये भी पता होता है कि वोल्टेज अक्रॉस द इंडक्टर इज गिवन बाय एल डी आई बाई डी टी. तो ये क्या हो जाएगा? एल हो जाएगा वी एल डी टी बाई डी आई। सो यूनिट की अगर हम बात करेंगे तो वोल्टेज का यूनिट क्या होगा, वोल्ट, इनटू टाइम का यूनिट क्या होगा, सेकेंड, ठीक है, और करंट की यूनिट क्या हो जाएगी, एम्पियर, एम्पियर, ठीक है। तो ये भी पॉसिबल है, वोल्ट सेकेंड पर एम्पियर, वेबर पर एम्पियर, ये भी सही है, ये भी सही है, और हेनरी भी सही है, ठीक है। तो ऑल ऑफ दिस, ऑल ऑफ द अबव इज द राइट आंसर फॉर दिस क्वेश्चन। Power factor of the following circuit will be zero: resistive, inductive, capacitive, both B and C. We know in case of resistive circuit, phi equal to 0 degree. So we say cos phi equal to 1. तो पावर फैक्टर यहाँ जीरो नहीं हुआ. In case of inductive circuit, we know in case of inductive and in case of capacitive circuit, है ना, in case of pure inductive circuit, तो जीरो तो देखो यहाँ पर क्या है ना, यहाँ पे प्योर इंडक्टिव होना चाहिए, क्योंकि इंडक्टिव सर्किट वो होता है, अगर सिर्फ इंडक्टिव सर्किट लिखा हुआ तो ये हो सकता है कि करंट वहाँ पे वोल्टेज से किसी पर्टिकुलर एंगल फाई एंगल से लेग कर रहा है, ठीक है, प्योर की बात नहीं हो रही है, देयर इज सम अमाउंट ऑफ रेजिस्टेंस इन द इंडक्टर, ओके। तो यहाँ पे प्योर इंडक्टेंस होना चाहिए था, यहाँ पे होना चाहिए था प्योर इंडक्टिव सर्किट, और यहाँ भी प्योर होना चाहिए, प्योर कैपेसिटिव सर्किट, ठीक है। तो जब प्योर की बात करेंगे तो उस केस में फाइव टू 90 डिग्री होता है, इंडक्टिव में भी होता है और कैपेसिटिव में होता है, तो उस केस में हम कह सकते हैं पावर फैक्टर कॉस 90 ये जीरो हो जाएगा, ठीक है। तो वहां पे हम ये कह सकते हैं एक ऑप्शन जो है डी, बोथ बी एंड सी, ये मोस्ट अप्रोप्रिएट आंसर है इस क्वेश्चन का, ठीक है। मोस्ट अप्रोप्रिएट आंसर फॉर दिस क्वेश्चन इज both B and C, that is inductive and capacitive circuit. In case of pure inductive and pure capacitive, uh, power factor angle is 90 degree. In case of pure inductive circuit, the current lags behind the applied voltage by an angle 90 degree, and in case of pure capacitive circuit, the current leads the applied voltage by an angle 90 degree. So we can say the power factor of pure inductive and pure capacitive is zero in this case, okay. So both B and C will be the right answer for this question. For delta connected circuit, the correct relationship is, we know in case of delta, in case of delta, line voltage equal to phase voltage, and line current equal to root 3 time into phase current. In case of star, line voltage equal to root 3 times into phase voltage, and line current equal to phase current. So this is the difference between the delta and star connected circuit. So the right answer for this question will be, in delta connected circuit, line voltage should be equal to the phase voltage. So this option is right. Again, line current equal to root 3 time into phase current. So this option is also right. Line voltage equal to root 3. No, this option is not right. So D is both A and B. So the right answer for this question will be both A and B. Okay. In purely resistive circuit, the average power is. So in purely resistive circuit, we know V equal to Vm sin omega t, and also current will be I equal to Im sin omega t. Okay. So if you multiply this, then this will give the instantaneous power, that is Vm Im sin square omega t, and we know cos 2 omega t can be written as 1 minus 2 sin square omega t. So Vm Im by 2, 1 minus cos 2 omega t, it can be written as, it can be written as, okay. So this is the instantaneous power. So in order to get the average power, what we should do, we have to integrate, we have to integrate this instantaneous power with respect to angle over one complete cycle, that is 0 to 2 pi divided by 2 pi. So power is a scalar quantity, so it should be So it should be integrate from 0 to 2 pi. Okay. So after integrating this, Vm Im by 2, 0 से 2 pi, 1 minus cos 2 omega t divided by 2 pi. So average power will be Vm Im by 4 pi. Integration of 1 should be 2 pi, and integration of cos 2 omega t will be sin 2 omega t by 2. So here d omega t is also present. तो एक वन का इंटीग्रेशन 2 पाई हो गया, कॉस का इंटीग्रेशन क्या होगा, साइन होगा माइनस में, ठीक है। कॉस का इंटीग्रेशन साइन होगा, माइनस में नहीं होगा, इंटीग्रेशन कर रहे हैं। और जब हम साइन 4 पाई 0 साइन 0 0, तो पूरा टर्म 0 हो जाएगा, तो बचेगा क्या, सिर्फ 2 पाई बचेगा, ठीक है। तो यहाँ से जब उसको इंटीग्रेट करोगे तो वो 2 पाई देगा, पाई पाई कैंसिल हो जाएगा, वी एम आई एम बाई 2 हो जाएगा। सो एवरेज पावर कितना आना चाहिए, वी एम आई एम बाई 2 आना चाहिए, ठीक है। वन का इंटीग्रेशन तो 2 पाई हो जाएगा, 0 से 2 पाई लिमिट है। अब कॉस का इंटीग्रेशन साइन हो जाएगा, तो एक बार 2 पाई पुट करोगे तो साइन 4 पाई 0 और साइन 0 0 हो जाएगा, तो पूरा टर्म 0 हो जाएगा, तो सिर्फ 2 पाई बचेगा। ठीक है। सो आंसर क्या होना चाहिए इसका, डबल, वन हाफ, वन फोर्थ इक्वल टू वन हाफ, है ना, आधा हो जाएगा मैक्सिमम पावर का। सो द राइट आंसर फॉर दिस क्वेश्चन वेरी ऑप्शन नंबर बी, दैट इज वन हाफ, वन हाफ आधा हो जाएगा। नेक्स्ट, इन एन ऑर्डिनरी ट्रांसफार्मर विच ऑफ द फॉलोइंग डजंट चेंज। ट्रांसफार्मर केस में वोल्टेज चेंज हो जाता है, करंट, फ्रीक्वेंसी, ऑल ऑफ द अबव। डजंट चेंज, सॉरी, जो चेंज नहीं होगा, तो क्या चेंज नहीं होगा, फ्रीक्वेंसी चेंज नहीं होती है। वी नो ट्रांसफार्मर इज अ डिवाइस which transform electrical energy from primary to secondary without a change in frequency. Okay, तो क्या चीज चेंज नहीं करती है, that is the frequency. तो right answer for this question will be option number C, that is frequency. Frequency doesn't change in case of transformer. So the right answer for this question will be option number C. The iron core in a transformer provides a path to main flux, low reluctance, low resistance, high conductivity. High conductivity. So the iron core in a transformer provides a low reluctance path to the main flux. So the right answer for this question will be option number A. When the mechanical power developed by a DC motor is maximum, then what should be back EMF? Back EMF is equal to the applied voltage. Back EMF is equal to 0. Back EMF is equal to half the applied voltage. None of the above. We know in case of DC motor, power is mechanical power is EB into mechanical power EB into IA. So in case of DC motor, in case of DC motor, what should be the equation? That is V minus EB equal to IARE. So what should be EB? V minus IARE, V minus IARE into IA. This is the mechanical power. So VIA minus IA का whole square R. So in order to get the mechanical power to be maximum, integration of mechanical power with respect to current should be 0. So minus RA 2IA इक्वल टू 0। तो यहाँ से V कितना आ जाएगा, ट्वाइस IARA. Okay, तो ये वोल्टेज मिल गया, दैट इज ट्वाइस IARA. तो पूछ रहा है द रिलेशन बिटवीन द बैक EMF एंड द अप्लाइड वोल्टेज. सो बैक EMF is nothing but V minus back EMF is V minus IARA. What is V? That is twice IARA minus IARA. So it should be IARA. Okay. And what is IARA in terms of supply voltage? V by 2. So in order to get the maximum, in order to get the mechanical power maximum, which is deployed by a DC motor, then the back EMF should be equal to half of the applied voltage. So this is applied voltage V. So the right answer for this question will be option number C. That is back EMF is equal to half the supply voltage in order to get the mechanical power maximum in case of DC motor. Okay. Now last question. Torque developed in a DC motor depends upon magnetic field, current flowing through the armature conductors, active length of the conductor, all of the above. So we know torque from the basic definition of torque, that is moment of force about an axis, that is F into R. And we know when a current carrying conductor is placed in a magnetic field, then the mechanical force experienced by a conductor is given by ILV into R, where I is the current, L is the length, B is the magnetic field. So first option is magnetic field. Yes, it is dependent upon the magnetic field. Second is the current flowing through the armature conductor. Yes, current. Current is also the right answer. Active length of the conductor. It is also right. Option D, all of them. So the right answer for this question will be all of the above. That is uh, magnetic field. It dependent upon the magnetic field, current flowing through the conductors, and the active length of the conductors. So the right answer for this question will be option number D. So this is all about this session. We have solved each and every problem of fundamental of electrical and electronics engineering paper. So before ending the session, please like and subscribe this channel, and also share this channel to maximum Polytechnic College of Bihar, which is under State Board of Technical Education. Okay. So hope you like the video. Thank you.